Hello guys, welcome to today's video. In today's video, we are going to talk about a graph of polynomials, quadratic polynomials, okay? Because in the previous video, we spoke about the Cartesian plane, XY plane, and we sketched graphs for constant polynomial and linear polynomial, right? So this is going to be the extended session of the previous session. So today we are going to sketch the graph of quadratic polynomial. Now I put number 3 here because we discussed constant, then we had linear polynomial in the last session, okay? On the left side, see here, I just put the main key points that we need when we sketch the graph of any polynomial, okay? We need end behavior of the graph, where it goes, that defines the directions. Then we need zeros of the graph, where it makes x-intercept, right? And then zeros where it cuts the graph. We see the multiplicity. If it is odd, then the graph will pass through, and if the multiplicity of 0 is even, it will just touch the x-intercept and it bounces over, okay? Then we make the coordinate table, okay? So we are going to follow the same process here, okay? So let's get started. First of all, what are quadratic polynomials? So can I write here? These are of the form ax squared plus bx plus c, where a must not be equal to 0 and a, b, c belongs to real number, okay? This is general form of quadratic polynomial subjected to some conditions, okay? You will get more clarity when we'll take some example and sketch its graph, okay? So let's take a quadratic polynomial expression. My expression here is, okay, equation. So I will take px equal to x squared minus 2x minus 8. Okay, this is my quadratic polynomial. Okay, so this is given to me. What I need to do is I have to sketch the graph of this quadratic polynomial, okay? Now what I will do here, because first of all I need to see the end behavior, okay? So for end behavior, generally what students do, they just look at the sign of the a. Now see here a is 1, okay? Here a is plus 1, b minus 2, c minus 8, okay? Because when we compare this equation with the general equation, we got a 1, b minus 2, c minus 8, okay? Now when they start with finding the end behavior of polynomial, right? End behavior, when they sketch the graph of polynomials, generally they look at a. If a is positive, then we know your graph will rise up, okay? Your graph will rise up. And when a is negative, so your graph will goes down, okay? Now see here, because the graph of quadratic polynomials are parabola, right? Parabola. So whenever you sketch the graph of any quadratic polynomial, you will get parabola, okay? We will discuss it later, the different cases that we can see when we sketch graph of quadratic polynomials. But just keep in mind, whenever you would like to sketch quadratic polynomial, you will always get parabola. Okay, so the graph of quadratic polynomial is parabola. Just keep this thing in your mind. Okay, so you check your end behavior looking at the sign of A, okay? But that's not my way, okay? Because I just want to know that how these things are happening, okay? So what I will do here, to check end behavior, here end behavior, okay? This is my step one, okay? To check the end behavior, what I will do, I will write this expression as px equal to, here x square common, here 1 minus 2 by x minus 8 by x square. Okay. Now, see here what I will do. If x tends toward positive infinity, if x tends toward positive infinity, okay, so here I can all right, take on here. This is x-axis, this is y, here y dash, here x dash, okay? Here minus infinity, this side positive infinity, this side positive infinity, this side minus infinity. When x tends toward infinity, when we put x infinity here, then what will happen to px or y? Okay, here we call it y. Okay, here you can represent it with y. Okay, because it's a function of x. So you can either, if, see here, there is nothing wrong. Okay, if I want to represent it with px, then here instead of y, I have to write px. Okay, but if I want to represent it with y, then this is okay. So do not worry. Okay, so now if x goes to infinity, then what happens to y? Y will be infinity square infinity. This is 2 by infinity 0, 8 by infinity square close to 0. Okay, so means our y will get infinity 2. If your x is minus infinity, then what will happen? Your y will get square of minus infinity. It will be infinity. It will tends toward infinity. Now see here, so x infinity, y infinity means this way, and here x minus infinity, y infinity means this way. Okay, so your graph end behavior is like rising up. Okay, so this thing is clear. Step number 1 is clear, that our graph is going to rise up. Okay, rise up. Good. All right, now step 2 is finding the zeros. Okay, now you have to find the zeros of this quadratic polynomial. Okay, now see here, there are various ways to find the zeros. Because this is quadratic polynomial, you can even split the middle term, right? Or you can just use the values of x. So whatever way you think is the best to find the zeros or solutions or the values of x, you can employ all those ways. Okay, So here, for example, this is y equal to x squared minus 2x minus 8. Okay, so if I have to find zeros, it means this whole equation is going to be 0. So here, middle term, x squared minus 4x plus 2x minus 8, 0. So here x minus 4 plus 2x minus 4 equal to 0. Here x minus 4 x plus 2 equal to 0. From here, value of x is plus 4. From here, the value of x is x equal to minus 2. Okay, so you have two zeros. Okay, so can I write, now see here, can I write these zeros in the expression form here? Okay, first of all I can erase it and I will write step number 2. I got my zeros at x equal to plus 4 and x equal to minus 2. Okay, this is number 3. This is number 3. This is number 3. Now, sorry, number 2. Now, number 3, step number 3 is multiplicity. Multiplicity. Now, if I have to represent the zeros in the expression form, then I can write x minus 4, x plus 2. Right? I hope you agree. Okay? I can write x minus 4 and x plus 2. Okay, now multiplicity means how many times this factor is going to appear, x minus a raised to the exponent k, or how many times this 0 is going to appear. Here the multiplicity is 1, here the multiplicity is 1, 2. It means at x equal to 4, because multiplicity is odd. Now see here, because multiplicity is odd, x minus alpha raised to the exponent k is odd. It means at x equal to 4, the curve will pass through the x-intercept, right? And here at x equal to minus 2, the curve will also pass through the x-intercept, because here the multiplicity is 1. Multiplicity 1 means that the curve will pass, or it cuts the horizontal axis. It passes through the horizontal axis at the x-intercept, okay, at x equal to 4, and same is going to happen at x equal to minus 2. I hope this thing is clear. So we can just visualize the situation here. 2, this is 2, this is 4, this is 6, this is 8, okay, this is 2, this is 4, this is 6, this is 8, this is 10, this is minus 2, minus 4, minus 6, minus 8, minus 10, here, if you extend it here, plus 10, okay, positive 10, negative 10 here, negative 2, negative 4, negative 6, negative 8, negative 10. Okay, just few values. Okay, just few values, because otherwise the graph is going to be, we have to use lots of area for this graph. Okay, so now see here, we got zeros at point x4, x2, x4, x2. So where is x4? x4 means here, and I can write here 4, 0, and there is 1 0 at minus 2. Okay, so minus 2, 0, the coordinate of this point, right? Then now step 4 is we have to draw the coordinate table. Okay, just throw in different values of x and check what's going to be the value of y. Okay, if now see here, if you put this is px equal to x square minus 2x minus 8. Okay, now if I am going to put value, this is y. Okay, this is the main expression or equation. Okay, polynomial function. So if I put x0 here, if I put x0, y is going to be 0, 0, minus 8. Okay, means x0, x0, y minus 8. What does it mean? It means this point, minus 0, minus 8. If you put x, x1, okay, if you put x1, so y will be 1 minus 2, 1 minus 2 minus 8 minus 9, okay. If you put x1, y will be minus 9. Where is x1? x1 is here, and y minus 9. Minus 9 means here, here. Okay, this is the point. This is the coordinate 1 minus 9. Okay, then if you put minus 1, okay, if you put minus 1, it will be minus 1 plus 2 minus 8, so it will be minus 5. Okay, minus 5, minus 1, minus 5, x minus 1, y minus 5. So here, this point, okay, this point 1, this point is minus 1, minus 5. Okay, then if you put what else? If you put x 2, if you put x2, 2 to 4, 4 minus 4 minus 8, minus 8y minus 8, 2y minus 8, minus 8, 2 minus 8, so it will be this point, 2 minus 8. Okay, if you put because for minus 2 we know it. Okay, if you put 3, if you put 3, then it's going to be 9 minus 6 minus 8, minus 8 minus 6 minus 14, and 9 minus 14 is 5, right? 5, so it's going to be minus 5. So for 3 minus 5, value 3 here and here, minus 5. This is 3 minus 5. Okay, what else? Minus 2. Okay, fine, we have enough values to draw the sketch the graph. Now if you combine, or sorry, if you trace all these points, okay, if you trace all these points, okay, if you trace all these points, see here, if you trace this, okay, if you trace all these points, if you trace all these points, it's going to be if you trace all these points, you are going to get a parabola. Okay? You are going to get parabola. Okay? I just joined all these points. Okay, so if you join all these points, you will get parabola. All right, you will get parabola. Okay, if you join all these points, you will get parabola. It has two. Now see here, it has two zeros. One zero is at -2, okay, and another is at 4, okay, and they have odd multiplicity. That's why the curve passes through the x-axis. Okay, so this is going to be your curve. Okay, this is going to be your curve. And what's the end behavior? See, end behavior, it is rising upward. Okay, so I hope this is clear to you. Okay, now what we will do is we will do it for we will put minus, and then we will see how it's going to behave. Okay, so now I hope I can erase this. Okay, I hope you understand. Okay, so this is quite simple. Okay. So this is my equation. Sorry, now here what I will do, I will put minus here. Okay, then here minus x squared. Okay, now end behavior. Okay, this is my graph. Sorry. Okay, so now see here end behavior. If x is infinity, now this is minus x squared. Minus is separate, x squared is separate. Okay, so what would happen if x is going to infinity? Y will tend toward minus infinity. This is x y negative y. Okay, here minus infinity, positive infinity, negative infinity. So if x infinity, y minus infinity, x infinity, y minus infinity means, what does it mean? It means this side. Okay, going downwards, right? Going downwards. And then if x is minus infinity, now see here, minus of minus infinity square means minus, right? Minus infinity square is infinity, but negative sign will stay here. So again, minus infinity. So x minus infinity, y minus infinity 2 means this way. See here, so it's like both are going down. Okay, so end behavior, we know this is going to be the end behavior. We have checked it. Okay, so now we will find the zeros. Okay, zeros are going to be the same because if we equate this to 0, we have to split the middle term, and then again the zeros are going to be with, I will here 2, 4, 6, 8, 10. Here minus 2, minus 4, minus 6, minus 8, minus 10. Okay, here 2, 4, 6, 8, 10 here, minus 2, minus 4, minus 6, minus 8, minus 10. Okay, this is 0. Okay, so the roots, sorry, not roots, the zeros for this polynomial expression is going to be the same as the previous one. Okay, so here previous one